Hi, welcome to this session on network security and forensics. In the last session, we were discussing a lot about the different IDSs, both commercial and non-commercial versions. Essentially, the intrusion detection system and prevention system actually tries to acquire evidence. Okay, so the question is, how are you going to acquire evidence? First one is, how are you going to acquire evidence? We will also see what are the types of configuration logs these systems have. We will also review something about SNORT before we actually look at a demo of SNORT. So, hopefully we will see whether we can give the installation instructions also, otherwise we will just show you demo of SNORT, and installation you could actually do it by yourself. Now, with respect to evidence acquisition, the intrusion detection system and the prevention system must be configured to ensure that you are able to capture any anomaly in or any scanning kind of activity, a reconnaissance or anomaly or scanning kind of activity, that is activities that are not normal in the network. The idea is that, so in this case a person has to be expert in configuring the network. See, it is in computer science it is told that garbage in garbage out. So, similarly if you take any intrusion detection, it has some kind of a language, okay, in which you have to specify to the intrusion detection software how to capture packets and how to find out patterns, and once you find out patterns, how do you react, and after that what do you do. So, these four issues have to be tackled by any intrusion detection software. Now, the configuration of sensors, for example, suppose I want to see whether someone is doing a port mapping, okay, then I should configure my intrusion detection system to scan for any port knocking that someone is trying to attempt. So, let us say he tries to knock, usually people knock ports like DNS, Telnet, FTP, all these ports, because that is what you actually leave it open in general in many of the times. Okay, so, the configuration of each of the sensor is very important in evidence acquisition. The second one is the location of the sensor is also important. So, you should find out where the attack or the malicious user is trying to enter and then put the device in the right place. One more important thing is your IDS should not be hackable. See, that is one of the reasons we actually try to suppress the IP address of the IDS. When you want to acquire evidence, okay, so when you see any malicious activity, you have to send alerts. Okay, these alerts you could actually send it to a particular machine through SNMP, like some kind of trap kind of messages, or you could also contact a server and send these alert messages. You should also look at the protocol information, and you should look at the flow information, you should look at the packet information. So, many of the intrusion detection devices provide facility to actually do or actually snoop into the packets and identify these kind of patterns. See, you can only look into the packets and identify the patterns. So, sometimes you might have to read the metadata, or sometimes you have to do the deep packet inspection in some many cases, and after this you have to correlate across multiple sensors. See, what you could do is you might have to correlate against the operating system logs. So, because operating systems also you could configure, if for example someone tries to do an unauthorized entry by logging in with some username and trying to attack using some dictionary based attack on passwords. Okay. So, if this happens, then you should be able to correlate against the operating system logs as well as the logs that are generated by your intrusion detection system. So, that is very important, and each of these intrusion detection systems work, or especially I am talking more with respect to SNORT. Okay. So, the SNORT and most of the intrusion detection systems are similar to SNORT. Okay, there could be, but each of these systems will have something known as a configuration file. Okay, the configuration file actually what it does is you actually have set something known as a rule. Okay. So, what is this rule? You actually, when the rule sets tells you that if you see a particular pattern emerging in the network traffic, what is the action you have to take. Okay. It could be as simple as just printing a log message by the IDS itself, or it could be very high end like blocking certain ports, which is actually the work of a firewall. Okay. So, your activity or the action can be anywhere between just logging to some serious action being taken. So, this have to be configured and set in a set of rules. This is known as the rule set, and then the rule set has a rule header, the rule body, etc. So, we will see all those things later. Many times, okay, you might have to do some sort of comprehensive logging, okay, and if you are going to do comprehensive logging, you fairly know that all packets or when you want to log all the time, you might have huge data, and this is also needs lot of CPU time, and there is heavy risk involved because of corruption of data and things like that, and preserving, see, as the data size increases, then storing it and preserving becomes an issue, because security is an issue with data anyway. Okay. And so, usually what you do is you collect all the data, but then filter it. All these filter rules can also be done with IDS. So, I collect the data and then filter it, and then based on the filtered data I take some kind of an action. This can be mentioned in the rule set. So, what we will do is, okay, now we have been generally talking about logging and things like that. So, now what we will try to do is we will try to take one specific example, like we will look at SNORT, okay, and we will see what are the functionalities of SNORT. We will look at some examples configuration of SNORT, and after this we will have a case study on SNORT. Okay. So, we will just take some simple examples, because SNORT is really powerful, and so we will not look into all the features of SNORT. We will just look at some simple example, one or two example for as a case study, and then see how SNORT actually identifies intrusions. Okay, SNORT is a widely used IDS. It was purchased by Cisco. It actually uses the libpcap utility. Okay. So, because it uses the libpcap, its functionality is similar to TCP dump as we have seen, but the best part of it is that it can do analysis from layer 2 to layer 4. Okay. And it also has the ability to do deep packet inspection. Of course, I mean with Wireshark, I mean we were actually doing it, we were not doing actually deep packet inspection, but at least we are looking into the packets. Okay. And as I told you, it has a open rule language. Okay. It has got a configuration file, and in the configuration file you can declare the variables and all that, and you can also specify the set of rules. Okay. And these rules are extremely flexible. You can actually change the rules, and in fact there are places where once they identify a pattern, they actually do some machine learning, and then I mean there are some kind of learnable intrusion detection systems. Okay. So, they actually learn what is the mentality of the attack or the way the attack is trying to happen, and then they actually do I mean they actually go and prevent the attacks much better. Okay. This because SNORT is extremely versatile. Okay. So, the rule additions and the rule language is very easy. Not only that, it has so one of the things you should be very careful about using network forensics tools is the support, commercial support. See, sometimes some tools are just distributed with no support. So, you might have a problem in using such kind of tools, but SNORT, I think almost many of the community people accept that it is a good software. Okay, intrusion detection software. Okay. And this also has a community with a commercial business model, therefore, life becomes much more easy as far as support is concerned. Okay. As long as the architecture of SNORT is concerned, okay, it uses libpcap to capture the packets, then it passes through 4 preprocessors. Okay, and these preprocessors essentially is for reassembly and protocol analysis. Okay. So, layer 3 it can reassemble fragments, and layer 4 also it can reassemble streams. Okay. Layer 5 it can reassemble sessions, and layer 6 it can reassemble transactions. This is very important, because if you remember the tool that we used, network miner, life was made very easy when we were able to capture the document as a whole, rather than we searching for the signature or the fingerprint of the particular document inside the email message. Okay. So, if a software can do this kind of activity, then it makes life pretty simple. So, now as I told you, it has an architecture where if there is an anomaly, then the alert can be sent to any layer. Okay. So, that is what we discussed. It can either be just logging or it can do activity of closing the connection also. So, after the reassembly and anomaly of detection, okay, information is handed out to the rule engine. Okay. So, rule engine is the one which specifies what action to be taken, and then after the rule engine specifies, it is sent to another engine. So, you could think of it as a sort of a pipeline, because I mean performance is a must in this. So, this architecture works in a sort of a pipeline, take the packets, do some sort of reassembly, I mean, and then reassembling the fragments and all that, give it to the next layer, that guy will do certain operations, he will give it to the next layer, and so on. And in this way, okay, you are able to achieve good performance. Okay. So, one of the things is you can even integrate SNMP based alerts. Okay. So, this is if you are using network management platform, which many organizations usually do, and then integrating with IDS can, I mean, provide a nice kind of GUI based integration. Okay. The most important aspect of SNORT is it has some configuration files. We see and I am talking with respect to Linux. Okay. So, you can see some of these configuration files. We will actually show it in a case study session, but for now we will let us understand that we will get an overall picture, so that when we do the case study we will understand the case study much better. Okay. So, what we will do is we will look at the snort.conf has global values of snorts that are declared. Okay. So, for example, I could monitor a set of HTTP servers and a set of IP address connections. So, for this I will declare a variable, and then for that variable I will assign bunch of IP addresses. Okay. So, in this way I can have global values of variables. Okay. I can define a network, whatever network is internal to my organization or external to my organization. So, it's very flexible. I mean, if you had done a course on networking, you would know that a router interconnects two networks. Okay. We were talking about firewalls and demilitarized zones, etc., in our previous lecture. So, so that we always configured it as an internal network where the IP addresses were different, and then we had external network where the IP addresses were different. So, with SNORT you will be able to identify or clearly specify about internal networks and external networks. Then you can also configure the preprocessors. Okay. Preprocessors are, you can, I mean, as I told you, you could look at specific ports, activities, etc. Okay. These can be configured. Then you can look at output processor configuration. Output processor is what is after the action is taken, what are you going to do. Okay. And then they usually call it as the rule chunks. Okay. So, all these things are available within this snort.conf. Okay. You can include certain files, and then you can specify the rules in a separate location and then point to those rules, etc. Okay. And if I have 100 rules files, I need not implement all the 100 rule files. I can even we can only specify 50 rules are enough for me for the time being. I will incorporate the other rules maybe later, or I will disable the other rules, etc. So, you have an option of enabling and disabling certain rules. For example, I want to set up a honeypot. Okay, in that case I will have to disable all the rules, so that when the attacker comes, I welcome the attacker to catch him. Okay. So, in that case I have to disable some of the rules. So, this can be done with SNORT, and the SNORT also puts the log. Okay. Just a slight deviation. I just wanted to tell you that, okay, when you are looking at OS forensics, operating system forensics, okay, this var log is very important. I mean, almost all the software that you put on Linux, okay, stores the log in var log. Okay, syslog, kernel log, and almost all the logs. So, this log files are very important, and SNORT also follows the same procedure. Okay. This is, we will see that this capability obtained by Linux using something known as a syslog feature. Okay, anyway, we will look at more details about the header. Okay, so the rule header actually tells you what is the action. So, what must be done if a match in sensor. So, the actions could be something like alert or log or pass the message or drop the message. So, this is, so the action could be any one of these activities. Okay. The next one, the rule header will specify is protocol. Okay. So, you can actually specify that the packets, if it is TCP or UDP or ICMP, I mean this, if you remember, this is similar to what we did in Wireshark. I mean we applied something known as filtering rules at the top, if you remember. So, this similar filtering rules is applicable for SNORT also. The source IP bar network and the port. Okay. So, probably in filtering we did not look at IP bar network, okay. We are looking only at IP addresses and ports when using Wireshark. So, in SNORT we will see that not only IP addresses, we could also look at network as such, okay, network using the network mask, okay, and the port number. And then you can also, the rule header will also specify the directional operator, I mean which is the source, which is the destination, okay. Usually left hand side of the rule is the source and the right hand side is the destination, but if you change the arrow, I mean even though we call source destination, it could be the other way around, okay. And then it also talks about a destination IP network and a destination port. So, let us look at an example of a rule header. So, here is an example of a rule header, okay. So, it says alert, okay, space TCP space any space any space, and then it has a right side pointed arrow, then 192.168.2.180 and then something inside, okay. So, what it tells you is that I can receive packet, a TCP packet from any connection, okay, any network and any port, but when it is directed towards 192.168.2.1 and 80 as we know is HTTP port, then create an alert, okay. That is the first line. So, you see that this rule is very flexible and easy. I mean you do not have a lot of English words, but at least this conveys what you should do. Similarly, the next line, okay. So, it tells you log all UDP packets that comes from 192.168.1.1 and port number 53, but not directed to the network 192.168.1.0 bar 24. So, this is when you put /24, then it becomes a network, okay, and the port is any port. So, this tells you that if someone, a DNS server is trying to respond to any of this, just put a log message, okay. The next one, as I told you that you can use external net and HTTP servers. Now, these are variables, okay. So, external net is defined, can be any network that is external to your network, and HTTP servers could be any HTTP server, and you could have a list of ports also, HTTP ports also. So, in this way, now you see if you look at the way these three examples are, first one is a very simple example, then we are addressing a network, and the third one we are addressing networks and machines together, and this could be bunch of machines and bunch of networks, okay. So, that is the advantage of SNORT. So, the last line is actually very powerful, it drops the packets, okay. So, the rules in short, okay, the basis for logging or not logging a packet, okay, and it can be more than one line in length, okay. So, if you want just similar to C program, I mean you just put a backslash and then you are good to go, you can go on extending, okay. So, you have a rule header and rule options, okay. The rule header can have action, addresses, ports and mask, and rule options can have messages, what to look, where to look, etc. What we will do is that in the next session we will look into some more details of SNORT. Thank you.